Hello students, welcome to our YouTube channel Physics for UG. So in this video today we shall discuss about phase transition, and also we shall derive the Clausius-Clapeyron equation by using two different methods. First using the concept of phase transition, and second by using Maxwell equations. First of all, let's understand what is phase. Students, you might have heard that phase. There are different phases, different states or different phases: solid phase, liquid phase, gaseous phase. So what is phase? A phase is any homogeneous and physically distinct part of a system which is separated from other parts by definite boundary. That is a distinctive part. Solid state, liquid phase, gaseous phase, there is one phase. Okay. What is phase transition? ट्रांजिशन का मतलब चेंज होना. व्हाट इज फेज ट्रांजिशन? फेज चेंज होना क्या होता है? द ट्रांसफॉर्मेशन ऑफ ए थर्मोडायनेमिक सिस्टम फ्रॉम वन फेज टू अनदर एट ए गिवन टेम्परेचर एंड प्रेशर इज कॉल्ड फेज ट्रांजिशन. दिस मीन्स स्टेट चेंज होना, एक फेज से दूसरा फेज को चेंज होना. किसी कंडीशन में टेम्परेचर सेम होना चाहिए, प्रेशर सेम होना चाहिए. तो इन कंडीशन में द ट्रांसफॉर्मेशन ऑफ ए सिस्टम फ्रॉम वन फेज टू अदर फेज इज कॉल्ड फेज ट्रांजिशन. लाइक लिक्विड टू गैस, गैस टू सॉलिड, and solid to gas. These are the different types of phase transitions. Okay, what is order of phase transition? It is the lowest order of the derivative of Gibbs function z, which is discontinuous at the phase transition. इसमें डेरिवेटिव जी को डेरिवेटिव करना है, तो इसके बारे में आगे ज़्यादा जानेंगे, पढ़ेंगे. तो लेट्स discuss the next part. What is the first order phase transition? First order. First of all, during this phase transition, temperature T, pressure P remains constant, but entropy and volume changes. Entropy और volume change होता है और temperature and pressure change नहीं होता है. इसको हम first order phase transition बोलते हैं. तो इसमें और क्या होता है? देर इज ऑलवेज absorption or emission of certain amount of heat called latent heat. So latent heat is the L, which is the latent means the hidden. There is some hidden amount of heat which is used during the phase transition, like solid melting to liquid, liquid boiling to gas, solid subliming to gas. So melting process, freezing process, sublimation process, evaporation process, all these are the process of first order phase transition. Okay, and all this process occurs due to a latent heat, because temperature remains constant. Then how this process occurs? There is a question comes to our mind that temperature remains constant, then how a solid becomes liquid and how a liquid becomes solid? How this is possible? Okay, टेम्परेचर चेंज होता है, लेकिन जब सॉलिड स्टेट से लिक्विड स्टेट को चेंज होता है, उस टाइम पे टेम्परेचर 0 डिग्री पे सेम रहता है, बिकॉज एट 0 डिग्री टेम्परेचर आइस मेल्ट्स टू वाटर, और आइस होना 0 टेम्परेचर में, तो 0 डिग्री सेल्सियस टेम्परेचर दोनों स्टेट एक साथ एग्जिस्ट करते हैं. इसीलिए हम बोलते हैं टेम्परेचर कांस्टेंट रहता है. तो एक दूसरा वाला हीट, दैट इज लैटेंट हीट, वो हिडन होके काम करता है. और हिडन होके काम करता है क्या मतलब क्या है? वो हिडन वाला हीट है. देयर इज सम हीट दैट इज हिडन इन द प्रोसेस एंड विच इज यूज्ड ऑफ इन द फेज ट्रांजिशन. दो द टेम्परेचर इज कांस्टेंट, टेम्परेचर कांस्टेंट रहता है, लेकिन फेज चेंज होता है. ओके, दिस इज फर्स्ट ऑर्डर फेज ट्रांजिशन. द नेक्स्ट डिस्कस अबाउट द सेकेंड ऑर्डर फेज ट्रांजिशन. ओके, सेकेंड ऑर्डर, द फेज ट्रांजिशंस इन व्हिच नो latent heat is involved. latent heat सिर्फ फर्स्ट ऑर्डर में इन्वॉल्व होता है. नर entropy and volume of the system changes are called second order phase transition. Entropy, volume चेंज नहीं होता है. These are called second order phase transition. लेकिन in first order entropy and volume changes. In second order entropy and volume does not change. For example, superconductors changes to ordinary conductor. Ferromagnetic materials becomes paramagnetic materials. The para becomes ferro becomes para, and superconductor becomes ordinary conductor. Superconductors means zero resistivity. But conductor has some resistivity. This is called ordinary conductor, this is superconductor. So इसी प्रकार की जो चेंज होता है, फेज ट्रांजिशन होता है, इसको हम क्या बोलते हैं? सेकेंड ऑर्डर फेज ट्रांजिशन बोलते हैं. दिस आर एग्जांपल्स ऑफ सेकेंड ऑर्डर फेज ट्रांजिशंस. ओके, नेक्स्ट very interesting part, there is we have to derive the Clausius-Clapeyron equation. So in this first method we shall derive this equation by using this phase transition concept. Okay, now in phase transition Gibbs function plays a very important role. The Gibbs function per unit mass has the same value in two phases. If S1, S2, V1, V2 are the entropies and volumes per unit mass in phase 1 and phase 2 respectively. So 1 का मतलब phase 1, 2 का मतलब phase 2 means phase change होता है, और 1 का मतलब वॉल्यूम, V1 का मतलब वॉल्यूम इन phase 1 and V2 मतलब वॉल्यूम इन phase 2 and S1 मतलब एंट्रोपी इन phase 1 and S2 मतलब एंट्रोपी इन phase 2. Okay. This is the formula for thermal potential dG equal to minus S dt plus VdP, where S is the entropy, T is the temperature, V is the volume, P is the pressure. So minus S dt plus VdP. You can write this function remains constant, so in that part, so minus, this is the first portion and this is the second part, minus S dt S1 dt plus V1 dP equal to minus S2 dt plus V2 dP from this equation. Phase 1 and phase 2. Okay, next part, take dt common. This one dt and this one also dt. Take dt common to take dt to the left side part. So what will be? That will be plus S2 dt in the left side part. So dt S2 minus S1, because S1 is already in the left side, that is minus S1, dt S2 minus S1. In the right side, dp V2 minus V1, this is V2 dp, and when you take this V1 to the right side, it will be negative. So V2 minus V1 whole dp. What is dp by dt? d by dt. This is dp by dt. Take dt to the right side and take V2 minus V1 to the left side, that is S2 minus S1 by V2 minus V1. This is equation number 1. Okay, now remember, if latent heat is taken into account, latent heat is the amount of heat given to the system or taking from it during small phase change. Phase change होने के समय जो टाइप का हीट हिडन काम करता है उसको लैटेंट हीट बोलते हैं. तो लैटेंट हीट गिवन टू ए सिस्टम और लैटेंट हीट टेकन अवे फ्रॉम द सिस्टम. सो L इक्वल टू T S2 minus S1, that is the amount of heat. T S2 minus S1, that is ds. L is the amount of heat. So S2 minus S1 equal to L by T. So put this L by T expression in this part. Remember one thing, actual definition of latent heat is actually Q equal to ml. That Q is the amount of heat and m is the mass and L is the latent heat. If mass is taken 1, then Q equal to L. Unit mass substance, then Q equal to L. That means for unit mass of substance, the latent heat is equal to the amount of heat required. So here latent heat L equal to Q is equal to T ds. That's why L equal to Q. That means for M is equal to 1, it is taken M equal to 1 because it is already written. For unit mass substance, we used L equal to T S2 minus S1. So S2 minus S1 equal to L by T. So dP by dt from equation 1 we get L by T B2 minus B1 because S2 minus S1 is L by T. So this part is the Clausius-Clapeyron latent heat equation. Let's derive the same equation by using the Maxwell relation. There is another easy part. The second Maxwell relation is given by del P by del T at constant volume and delta S by delta V at constant temperature. Look at here, T B replaced, here V T exchanged, del P del S. Okay, as you know, delta S equal delta Q by T because from second law of thermodynamics dq equal to TdS. So ds will be dq by T. So del P by del T, this part remains same. In the right side part delta S, in place of delta S we use del Q by T. T is taken out because in this part T is constant, so it can be easily taken out. So del P by del T at constant V equal to L by T into delta V because delta Q equal to ml. For unit mass of material, delta Q equal to L, put delta Q equal to L by T, this dV we can write delta V. So del P by del T at constant V equal to L by T into delta V is the change in volume, that we can write Vf minus Vi also. So Vi is the initial volume and Vf is the final volume and initial volume. So dV by dt equal to L by T V minus Vi. This is also known as Clausius-Clapeyron equation by using, this is derived by using Maxwell's thermodynamic relation. Thank you. If you like this video, then press the like button, share the channel and subscribe the channel. Thank you.